Hi everyone, what is the standard error of a regression? That's what we're going to look at today, and we're going to compute it. So here we've got a simple linear regression model. Dependent variables house price, R is nominal interest rate. We've got some output here. We're asked to calculate the standard error of the regression. First of all, what is a standard error? Well, let's dependent variable, let that be y, exponential variable let it be x. Then what we have is that the observed value is equal to a predicted value for each observation plus the residual. The standard error of the regression is defined as the positive square root of the variance of the residual. This standard error is like a standard deviation. It can't be negative. And one way to think about it is that the closer it is to zero, it means like the better the fit of your model to the data. Better in the sense of, I'm going to explain now. So here we've got two cases. We're regressing log of house price on interest rate. In this case, these red lines denote the distance from the observed to the fitted line. Compare that to the second scenario. Which fit do you think is better? It's the second case, right? Because the line is closer. We managed to find a line that's closer to the dots. So standard error for this case would be smaller than for this case. So now let's compute it. The variance of the residual is given by this expression. It's the residual sum of squares, also known as the sum of squares error. This is the notation they're using here, divided by number of observations minus number of parameters in the model. So in this case we have residual sum of squares is 42.307 divided by, right, what is n? Sample size. We're going to have to calculate it. Right, okay, this is another good exercise. We've got monthly data. We're starting from January 1990 and we're ending on December 1994. So each year, and you've got to take care of this one. So year 1 we've got 12 observations. Year 2 corresponding to 1991 we've got 24. So how many by the end time we've reached 1994? Well, it's easy. Some students just think it's 4 years between 1990 and 94, but it's not. It's 5 years. So number of observations is 5 times 12. 60 observations. So here it's 60 n minus number of parameters in the mean part of the model 1, 2, intercept and slope, simple linear regression 2. So that gives us the variance of the residual, the standard error, which is denoting by S subscript E. This pen is sticking today. Equals the positive square root of this guy here. So I can write that down. And then just do the computation, put in your calculator, and you get 0.8541. Okay, so that's the standard error. Amongst other uses, we can use it to calculate the standard error of the coefficients. Okay, so that's it for today. I'm just looking ahead. Computation of the term r square. Now, if you look at the data that we're given here, and if you already know how to compute r square for the usual problem, you're going to see there's actually something you have to think about. You might be thinking to yourself, oh, is something missing here to calculate r square? So that's something to think about, and I'll solve it on another video. Cheers!